Hello students, welcome to online maths classroom. This is part 2 of your topic relations and functions, and in this part we'll discuss solution of your NCERT exercise 1.2. So let us start with it. So let us start with types of functions. In our earlier class plus 1 we have studied about special type of functions like identity function, constant function, polynomial function, rational function, our modulus function, signum function, etc. And their graphs we have also done in class 11. Their addition, subtraction, multiplication and division of two functions, this has already been studied, right? Now the functions, the concept of function, this is very important not only in mathematics but in some other disciplines also, right? So let us start with studying here different types of functions. So let us consider the functions f1, f2, f3 and f4, and they are depicted by these diagrams. So let us start with your f1. Now we will have observation. This is called as arrow diagram. So we will observe these functions f1, f2, f3, f4 one by one, right? So we observe that the images of distinct elements of x1, see, different elements of x1 under the function f1, under this function f1 are distinct, okay? Different elements, okay? One is having A, 2 is having B, image as B, 3 is having image as D, 4 is having image as C, right? Means the different elements, distinct elements of x1 are having your distinct images, right? And see, you can also see that for f2, you can see for f2, two distinct elements 1 and 2, see from here, this 1 and 2, they are having the same image B, okay? They have same image B. Further, there are some elements like E and F in x2 also. See, this E and F are there who are not having any image, okay? Any element of x1 whose image is there under this f1, right? Here also you can find it is not having, they are not having any pre-image. Also E and F here are not having any pre-image, while all elements of x3, right, all elements of x3, see here, are images of some elements of x1, see from here. Now observe function f3, you can see here that the first two elements are having same image A, okay? But one thing is satisfied here, that every one of x1 is getting a image, and every of this, all these images are having a pre-image, okay? Means there is no element left like here in E and F were left, and okay, all the elements of this image set, they are having a pre-image, whether it is unique or not, but they are having pre-image, okay? And see, observe this, your function f4. Here also you can see that here the function, every element is having your unique image. Everybody has different image, and moreover all the elements of this set are having a pre-image, okay? There is no like these two diagrams, okay? Here E and F were left, so both these diagrams cover the situation. Here they are having your means two different elements are having same image, and here the different elements are having different images, right? So let us define a function now. A function f mapping from x to y is said to be 1, 1, 1, 1 or injective if the images of distinct elements of x under f are distinct, okay? See, images are distinct, see from here. So in this function, images are distinct. 1 is having A, 2 is having B, 3 is having D, 4 is having C. So this one and moreover this one, okay? If they have distinct images, for every x1, x2 belongs to x, f of x1 is equal to f of x2 implies x1 is equal to x2, okay? That if your f of x1 is equal to f of x2, that means your x1 is also equal to x2. That means the function is 1, 1. Otherwise it is called as many 1, right? So we can see that function f1 and f4 are 1, 1, and the function f2 and f3, they are many 1, okay? 1, 1, they are having this one, and this one they are having unique images, and these are having many one means as two elements are having same image, right, from here. Okay, so definition number 6, which is there, a function f mapping from x to y is said to be subjective or onto. Okay, if every element of y is an image of some element of x under f. Okay, that is for every y belonging to y, right? For onto function we have to see this, the second set. For every y belonging to y, there exists an element x in x such that f of x is equal to y, right? So see from here the functions f3 and f4. The functions f3 and f4, they are onto. Okay, they both are onto. Why? Because all the elements, okay, all the elements here, they are image of some element of this your set x1 and x1 here, right? So that means that you are getting, means in we watch here the codomain set, right? That codomain is having every element is having your, means every one is here is the image of some element of this. Okay, and like here this is not onto y because e and f, some elements are left which are not having any pre-image. Okay, so this is why this your f1 and f2 are not onto. Then comes the bijective. Bijective means f mapping from x to y is said to be 1 1 and onto. If both 1 1 and onto, then we see it all, it is called as bijective. Okay, it is both 1 1 and onto. So your f4 was depicting the example for 1 1 and onto, both 1 1 and onto function, right? So let us see an example, that let A be the set of all 50 students of class 10th in school. F is mapping from A to N be function defined by fx equal to roll number of students of x, right? So show that f is 1 1 but not on. Okay, so let us see, this is a simple example. Now from here, no two different students of the class can have same roll number. Okay, means everyone will be having a unique roll number. So this function will be 1 1. Okay, now we can assume without any loss of generality that roll numbers of students are from 1 to 50. So this implies that 51 is not going to be a roll number, okay, of any student of the class. So that 51 can not be the image of any element of x under it, right? As you know that the counting numbers are infinite, right? So they are not just finished up to 50, right? So that's why as their number of students are 50, so 51 will not be belonging to any roll number, means it will not be roll number of any student of that class, right? So that means this function will not behave as onto. Okay, it will not behave as onto, right? Example number 8, show that function mapping from n to n given by fx equal to 2x is 1 1 but not onto. So let us see how to prove 1 1. A function f is 1 1 if for f of x1 equal to f of x2, that means 2x1 equal to 2x2 implies x1 is equal to x2. Further, f is, so that means it is 1 1, right? F is not onto y because for 1 belonging to n, there does not exist any x in n such that f of x is equal to 2x, which is equal to 1. Okay, because see, when will 2x be equal to 1? That means 2 into say half, 2 into your half will be 1, right? But half is not there. Okay, half is not a natural number. So that's why there is no such value, okay, which will give me your 2x equal to 1 in the system of natural numbers, right? So this function is not on. Example 10, show that the function f mapping from n to n given by f of 1 equal to f of 2 equal to 1, okay, and fx equal to x minus 1, okay, for every x greater than 2 is onto but not 1 1. So let us see. So see, f is not 1 1. Why? Because f of 1 and f of 2 both are having same value as 1. Okay, same image as 1. But f is on 2. Why? Given that for y belonging to n, right? Y belonging to n, y not equal to 1, we can choose x as y plus 1, right? We can choose your x as y plus 1, right? Y plus 1. So when we put f of, in place of x, when we will put f of y plus 1, it will be y plus 1 minus 1, which is equal to y. That means your f of x equal to y, right? Also for 1 belonging to n, we have f of 1 equal to 1. So that's why this function is your onto but not 1. Example number 11, a function is mapping from R to R defined by fx equal to x square, neither 1 1 nor onto. So see, it's again a parabolic function, quadratic polynomial, graph is a parabola, and this is your 0. Now see, the values are repeating, right? As f of 1 is 1 and f of minus 1 is 1. So clearly the function, same image they are having for two different elements. So that means f is not 1. Also, the element minus 2 in the codomain are minus 2. Okay, minus 2. See, as we can see that your x square is equal to minus 2. Okay, x square equal to minus 2, right? If we take that in codomain, we will find that there will be, it will not be the image of any element of x in R. Why? Because we are dealing with real numbers, and x is equal to your square root of minus 2 is not allowed in real number system. Okay, it is not allowed. So that means there is this element minus 2 in the codomain R is not the image of any element of x in the domain R, right? That's why if it's not onto. Okay, so let us start with exercise 1.2. Show that the function f mapping from your R star to R star, right, defined by fx equal to 1 by x is 1 1 and onto, where R star is the set of all non-zero real numbers, right? Non-zero real numbers, keep in mind. Is the result true if the domain R star is replaced by your n with codomain being same as R star? So say f of x is 1 by x. So you know how to prove 1 1. I'll take two different elements x1 x2 belonging to R star with f of x1 equal to f of x2, which implies your 1 by x1 equal to 1 by x2. Cross multiply x1 equal to x2 implies f is 1 1. Okay. Now again, fx equal to y, what does it means? Fx equal to y means it is equal to 1 by x. So cross multiply xy is 1 and x is 1 by 1. Right. So you remember your questions in class 11th we have done. The finding out the domain portion is the checking of your one-oneness, and how we check the range, right? We converted your fx equal to y, right? And that conversion principle is also used here to prove, check the range, right? Now given any y belongs to R star, the codomain we can choose x as 1 upon y, such that your fx equal to your 1 upon x, fx equal to 1 upon x, which is your 1 upon the value of x is 1 upon y, which is equal to y. Okay, thus every element in the codomain has pre-image in the domain under f, therefore f is onto, right? Because R star is the set of all non-zero real numbers, and you know this is existing only when x is not equal to 0. Okay, right. Now see, the second part is if f is mapping from n to R star, that means I change the domain to R star to n. Then what will happen? Fx is equal to 1 by x, it will be 1 1 again, right? Since x1 x2 belongs to an, f of x1 equal to f of x2, the again same thing that we have done here is followed. But f is not onto. Why? If I take 2, an element 2 belongs to R star. Okay, so 2 is not the reciprocal of any natural number. That is, there exists no natural number x such that f of x equal to 2 or 1 by x equal to 2, right? Because x equal to half is not a natural number, right? So this function is not onto. It is 1 1 but not onto. Number 2 is check the injectivity and surjectivity of the following functions. First is f is mapping from n to n, fx is x square. So let us start with it. Injectivity means one-oneness. Surjectivity means onto function. And bijectivity means both. So first is f mapping from n to n, fx equal to x square. This is domain, this is codomain. So check the one-oneness. Let x1, x2 belongs to the domain n. F of x1 equal to f of x2, right? Now put here, see from here, x1 square equal to x2 square, x1 equal to plus minus x2. Now rejecting the negative sign, as you know that x1 and x2 are two natural numbers, so they are positive. So x1 equal to x2 we get. So that means f is injective, that is 1 1. Surjective means onto. So put the values of x as, keep on putting the values as 1, 2, 3, right, which will belong to the domain n, right. So what values you will get? When I will put 1 here, I'll get 1 square, 2 square, 3 square. Now you can say it is, the values are 1, 4, 9. So where are your 2, 3, right, your 5, 6, means this set is not covering the set of whole natural numbers, so which is not codomain n, right. So that means because such elements are not there, so f is not surjective. F is injective but not surjective. 1 1 but not onto. So let us see for z to z fx equal to x square. Z means integer. So 1 1 is x1 x2 belongs to the domain f of x1 equal to f of x2, x1 square equal to x2 square, x1 equal to plus minus x2. Now negative sign cannot be rejected. Why? Because integers are positive and negative as well, right. So how is it possible? F of x1 equal to f of x2 must imply either x1 equal to x2, okay, but it is implying that it is equal to plus minus x2, means it is not 1 1. So why? See an example like 2 belongs to z and minus 2 is also belonging to z. Both are not equal. But for this, f of 2 is 2 square, that is 4, and f of minus 2 is again 4, right? So values are same, but here the elements are not same. And ontoness, now put x value as 0, all the integers 0 plus minus 1 plus minus 2, so on, so, because it is belonging to domain z. So see the range. What is happening to the range now? When I'll put 0, I'll get 0, then I'll get 1, then I'll put 4, then I'll put 9. Now, does it cover whole integers, whole set of integer? No, it is not equal to codomain of set, because 2, minus 2, etc. they are not belonging to the range. So it is not surjective, hence neither injective nor surjective, neither 1 1 nor onto. Next is your f is mapping from R to R, real to real, fx equal to x square. So let us now f is mapping from R to R, fx equal to x square, right? Is f injective? No, because in second part what we have done, the same thing follows here. You will get like x1 is equal to plus minus x2, okay, plus minus x2. So this function is your not 1 1, okay, it is not 1 1. So for surjective, let us see range set, okay, set of all positive real numbers we are talking. Why? Because you know your x square is all positive real numbers, right? Because the square of any number will always be positive, which will not cover the complete codomain R, real number. So again, it is neither injective nor surjective. Fourth is f mapping from n to n, fx equal to x cube. Now injectiveness. Let x1, x2 again belongs to the domain. So f of x1 equal to f of x2, x1 cube equal to x2 cube. So x1 equal to x2. Why? Because you know if the cube plus cube is equal to plus cube, then x1 equal to x2. Okay, if minus are equal, then it will be the minuses will be equal. So f is your clearly 1 1. Okay, for natural numbers even, right? Because here we are dealing with natural numbers. So x1 cube equal to x2 cube means x1 equal to x2, right? So f is surjective. Let us see, is it surjective or not? So take your elements of domain like the natural numbers 1, 2, 3. See whether I get all the natural numbers. I'll get 1 cube as 1, 2 cube, 3 cube, means such kind of elements, which is not equal to the complete codomain n, right? Like elements like 2, 3, 5, 8, etc. are not there. So it is not surjective. So it is 1, 1, but not onto. Number 5 is your z to z, integer to integer, x cube. So let us quickly go for it. Again, f of x1, x1, x2 belongs to domain z. F of x1 equal to f of x2, x1 cube equal to x2 cube, x1 equal to x2, right? So f is 1, 1. Okay, f is 1, 1. Okay, because plus cubes are equal, so x1 equal to x2. For surjectiveness, let's take your some integers like some positive, negative, and zeros. So while taking the cubes, I'll get elements like this. So again, some are missing, 2, minus 2, 3, minus 3. So complete range is not there, right? So I'm not getting, this range is not equal to the codomain set. So it is not surjective. So it is injective, but not surjective. Number 3 is prove that greatest integer function f mapping from R to R given by fx equal to greatest integer function x, neither 1 nor onto, where x greater this denotes greatest integer less than or equal to x. Now greatest integer function is your f mapping from R to R given by fx equal to integer x, where this just denotes the greatest integer less than or equal to x. Now see the oneness. So you must know about the behavior of greatest integer function. Like if we take x1 as 2.5 and x2 as 2.8, both are your belonging to domain R, right? So you know the greatest integer operated means, see, the two elements are different. 2.5, 2.8 are different, but f of x1 is equal to f of 2.5 will give you the value 2, because you know 2.5 is lying between 2 and 3, but to the left the full integer is 2, so the value is 2. Again 2.8 to the left of 2.8 is only 2, so only 2 will be the answer. So see here, f of x1 equal to f of x2 2, but your x1 and x2 both are not equal, so means f is not 1 1. For the range, you know fx equal to integer function, so that means you will get the set of all integers, right? Because this integer function is always an integer. So I'm not getting the complete real number set. So means range is not equal to codomain. So f is not onto. So it is neither 1 1 nor onto. Next is your f mapping from R to R given by fx equal to modulus x is neither 1 1 nor onto, where mod x is x if x is positive or 0, and it is minus x if x is negative. So see the behavior of modulus function. F is 1 1. Again let's take x1 as -1, x2 as 1. Both belong to the domain R. Now f of x1, that is f of -1, mod of -1 is 1. F of x2, f of 1, mod of 1 is 1. Now see here again, f of x1 equal to f of x2 equal to 1, but your x1 is not equal to x2. So that means my function is not 1 1. See the range. Now range here will be the set of all positive real numbers, because whatever you will get after operating through the modulus, you will get all positive real numbers. No doubt 0 will be there, but no negative real numbers will be there. So okay, that means the range is not equal to codomain, that codomain R. So it is not onto. So it is neither 1 1 nor onto. Number 5 is signum function. Signum function you know very well, f mapping from R to R, and these three values are there. 1 for x positive, 0 for x equal to 0, -1 if x is negative, is neither 1 1 nor onto. So let us see the oneness. See from here, I take two different elements x1 and x2, x1 2, x2, x1 as 2, x2 as 3. So f of x1 equal to f of 2, right, and it is equal to 1. Okay, because for all positive numbers the value is just 1. For f of x2 it is also 1. So again, right, again what happens, f of x1 equal to f of x2 equal to 1, but x1 and x2 are not equal. Similarly for negative also you can go for it. If x1 is -2, x2 is -3, so you know f of -2 will be -1, because for negative numbers the value is -1. Here also it is -1. So again f of x1 equal to f of x2 is -1, but your x1 is not equal to x2, so f is not 1 1. Is f onto? Now see, f of x1 is 1, only three values are there. For positive numbers it is having value 1, for 0 it is 0, for negative ones it is having -1. So range set is just of three elements, which is not equal to the codomain R. So f is not onto, hence it is neither 1 1 nor onto. Number 6 is, let a is 1 2 3, b is 4 5 6 7, and let this is the function 1 4 2 5 3 6 be a function from a to b. Show that f is 1 1. So see the arrow diagram from here. 1 2 3 elements are there from the domain set, and this is your 4 5 6 7. Okay, now you have to show that it is a 1 1. Okay, 1 1 is just concerned with that all the elements from your set E should get a unique image in set B. Okay, 1 1ness is just concerned about it, and ontoness is that every element in the codomain here should get a unique pre-image, should get a pre-image rather. Okay, should get a pre-image, right? So you can see 1 is having, f of 1 is 4, f of 2 is 5, f of 3 is 6, 2 is getting 5, 3 is getting 6. So different elements 1, 2, 3 are having different images in codomain B. That means this function is 1, 1. Now is it onto? No, it is not onto. Why? Because an element 7 is there which is not getting any pre-image in your setting. Okay, so this function is not onto. Number 7 is, in each of the following cases state whether the function is 1, 1, onto or bijective. So f is mapping from R to R defined by fx equal to 3 minus 4x. So let us check the 1, 1ness. Again, let x1, x2 belongs to domain R. F of x1 equal to f of x2 implies 3 minus 4x1 equal to 3 minus 4x2. Okay, so you can see that what can I do is I will just bring from here this my x1 and x2. So firstly I'll subtract 3. Okay, so what will I get? A subtraction of 3 will give me minus 4x1 equal to minus 4x2. Okay, and then divide by minus 4, I'll get it as x1 equal to x2. Okay, so that means the function is clearly 1, 1. For ontoness, let us see, let y be an element of codomain R and suppose that y equal to fx. Okay, so y is your 3 minus 4x, right, from here. Now change this y value in terms of x. So x becomes 3 minus y by 4. So x is equal to 3 minus y by 4 belongs to domain R. For each y belongs to codomain, right? Now fx equal to 3 f of this 3 minus 4x, right? So put here the value of this x. So you get it equal to y. See, 3 minus 4 times this complete, 4 gets cancelled, and it is 3 minus 3 plus y, which is equal to y. So our supposition says that y equal to fx is correct. Hence codomain equal to range, function is onto. Hence it is both 1, 1 and onto, that is bijective. For the second one, f mapping from R to R, fx is 1 plus x square. So let us take x1, x2 belongs to R such that f of x1 equal to f of x2. So see from here, 1 plus x1 square equal to 1 plus x2 square. So this gets cancelled, x1 square equal to x2 square, x1 equal to plus minus x2, right? So negative sign can't be rejected because this numbers, say if it would have been the natural number system, so I would have rejected the negative sign as the negatives do not belong to natural number system. But here again, you know that real numbers and integers they both carry your this positive and negative numbers, right? So that means x1, x2 belongs to R. So that's why we cannot reject the negative sign. So f of x1 equal to f of x2 implies x1 equal to plus minus x2, not x1 equal to x2 means. So f is not 1, right? Because f of 1 is your 2 and f of minus 1 again is 2, right? So 1 is not equal to minus 1, but f of 1 equal to f of minus 1, right? So function is not 1, 1. Ontoness, the range set is your fx equal to 1 plus x square, x belongs to R. Now you see this is your positive number, right? Because x square is positive and some positive plus 1 will be your x square greater than equal to 0, right? Because if this x is going to be 0 in some case, some real number, because this result will always be positive, and you can say x square is positive, so my thing is always greater than equal to 1. Okay, because x square in positive you are adding 1, so the result is greater than equal to 1. So that means you know it is your semi-closed interval 1 to infinity, right? Which is again not equal to the codomain of all real numbers. So f is not onto. Hence it is neither 1, 1 nor onto. Number 8 is, let AB be sets show that f mapping from A cross B to B cross A such that f of AB equal to f of BA is bijective. Right now we are dealing with ordered pairs now. So again, when you were dealing with simple elements, so you were supposing like x1 and x2 are two elements. Now you have to suppose two different ordered pairs, A, B, C, D belonging to A cross B. Okay, with f of AB, this rule is there, f of AB is equal to BA. Then BA is equal to DC, right? Your BA is equal to DC. Okay, BA is equal to DC, right? So why is there? Because this rule is there. F of AB means C. The element B has shifted to the X place and A has shifted to the Y place. That means if I take f of AB equal to f of CD, so what is happening? It will become your BA, okay, BA, and it will become DC, okay, as per the given rule. Now equating these ordered pairs, what will I get? I'll get B as equal to D and A equal to C, right? This thing implies that AB equal to CD. If I'll arrange it, I'll get AB equal to CD, okay? So that means my F is injective or 1, which is the only requirement, because if f of x1 equal to f of x2, then x1 should be equal to x2. Now for ontoness, let us take BA belongs to codomain, okay? For ontoness, we always take an element here in B cross A. So an element in B cross A will be of the kind BA belongs to codomain B cross A. Then there exists your AB belongs to domain A cross B, such that your given rule f of AB equal to f of BA, right? Thus every BA belongs to B cross A is the image of AB belongs to your A cross B, right? Because if your you see that the images are getting just twisted here. So for every BA belongs to B cross A, there is image of AB belongs to A cross B. Definitely it is going to be onto. Hence it is both 1, 1 and onto, that is bijective. Okay. Now number 9 is your F is mapping from n to n, defined by Fn is n plus 1 by 2 if n is odd, and n by 2 if n is even, for n belonging to n. Now state whether the function is onto, 1, 1 or bijective. Justify the answer. So this is C. Be careful that for odd even functions, two different definings are given. So to examine whether f is 1, 1, let us start with your 3 belongs to n and 4 belongs to n. Two different values, out of which one is odd, one is even. Okay, you can go for two different even values, two different odd values also, right? But we are taking one even, one odd. So as 3 is not equal to 4 and say 3 belongs to n, which is odd, so what will I get? Like this rule will be applied for odd numbers. So f of 3 will be equal to 3 plus 1 by 2, that is 2. Okay, and C, 4 belongs to n. So then this rule will be applied. So it will be a f of 4 will be 4 by 2, which is 2. So what happened? F of 3 is equal to f of 4, but you know 3 is not equal to 4. This is the case of not 1, 1 function. To examine whether f is onto, okay, let us find the range of f. We will find the range. Now see, the range is going to be, what kind of range is it going? See, if I put say odd numbers, n as 1, 3, 5, 2n minus 1. So what kind of numbers I'll get? See from here. When I'll put my f of 1, what will I get? I'll get this here 1 plus 1 by 2, that is 1. F of 3, I'll get 3 plus 1 by 2 as 2. Your f of 5 as 5 plus 1 by 2, that is 3, and so on. So, and f of 2n minus 1, this is odd numbers. It will be 2n minus 1 plus 1 by 2, which is n, and so on. So, right. So let us take when I put n as even, like 2, 4, 6, 2n. So f of 2 is, now the formula is n by 2. This 2 by 2 is 1. F of 4 is 4 by 2 is 2. F of 6 is 6 by 2 is 3. F of 2n is 2n by 2 is n. So range is your like 1, 2, 3, so on, so up to n, which is your codomain n, right? Means, so this function is going to be discovering range is equal to codomain. That means my function is onto. So it is not 1, 1 but onto. So it is not bijective, because for being bijective it should be both 1, 1 and onto. And while discussing your onto, whether for y belongs to codomain, there are 2 or more than 2 x belongs to domain for which f of x equal to y, right? So it is never going to be 1, 1. Here in the above example, for y equal to 1 belongs to codomain n, there are 2 values of x, 2 pre-images, like x1, x2 belongs to domain n, for which f of x equal to y. Okay, because for odd and even the result is described, so it is not 1, 1. Okay. Again, number 10 is let a is equal to r minus 3, means all real numbers except 3. B is equal to r minus 1, all real numbers except 1. That's why instead of writing it again and again, they are denoted by a and b. Consider the function f mapping from your a to b. So originally a, b are they. By defined by fx equal to x minus 2 upon x minus 3 is f 1, 1 and on to justify your answer. So let us take two elements x1, x2 belongs to a such that f of x1 equal to f of x2. Put it here, x1 minus 2 upon x1 minus 3 equal to x2 minus 2 upon x2 minus 3, right? Now cross multiply, you'll get a result and you will get x1 equal to x2. So clearly f is your 1, 1. Now let y equal to fx and fx is your this. Now I have to convert it to x. So cross multiply, x minus 3y equal to x minus 2. Open it, okay? And definitely you're going to get it as x equal to 3y minus 2 upon y minus 1. Okay? Now you know this is existing when y is not equal to 1. That is when y belongs to codomain B. See from here. Okay? It is already r minus 1. So there exists x equal to 3y minus 2 upon y minus 1 belongs to a, that is r minus 3, such that f of x equal to. Okay? Now take f of x and put this value of x. If it gives you y, then the result is proved. So see, f of x is this, right? F of x is your given here like this. Okay, now put your value of x here, 3y minus 2 upon y minus 1 minus 2, 3y minus 2 upon y minus 1 minus 3. Take LCM and you will get it as y. So f of x equal to y, right? So we get the function is onto. Number 11 is, let f mapping from R to R be defined as fx equal to x power 4. Choose the correct answer. F is 1 1 onto, many 1 onto, 1 1 but not onto, neither 1 1 nor onto. Okay, x4. So let us start. F mapping from R to R, fx is this. So it is not 1 1. You have seen the fx equal to x square case, right? So see, as 2 and minus 2 both belong to real numbers. Okay, domain, which is the domain. So f of 2 is 2 raised to power 4, that is 16. F of minus 2 is again your 16. F of 2 equal to f of minus 2, but 2 is not equal to minus 2. So again f of x1 equal to f of x2, but x1 not equal to x2. So it is not 1 1. Is it onto? Let us see which type of range it is giving me. So fx equal to x raised to power 4. X belongs to R. You know this x power 4 is always positive for all real number x. So that means you will be getting your fx as greater than equal to 0. And this means 0 infinity, which is not your complete codomain of real numbers. So means f is not onto. So it is neither 1 1 nor onto. So that means my option number D is correct. So this option is correct. Okay. Number 12 is f mapping from R to R be defined as fx equal to 3x. Choose the correct answer. So again 1 1 ontoness we need to check. So let us start fx equal to 3x. Let x1 x2 belongs to R such that f of x1 equal to f of x2. 3x1 equal to 3x2 divided by 3, I'll get x1 equal to x2. So it is going to be 1 1. Ontoness, let y belongs to codomain R. Y equal to fx. Y means this is 3x. So x becomes y by 3, which belongs to domain R. For every y belongs to codomain R, right? So C means if 3, if you are getting say a real number, say your real number you are getting. So if your y equal to fx and y equal to 3x, then x equal to y by 3 is also belonging to, means it is also going to be a real number. Okay, so it is going to be belonging to domain R, right? And now take f of x and you put in place of x your y by 3. If it turns out to be y, see 3x is 3 times y, 3 times y by 3, which is your 3 gets cancelled and you get it as y. So range becomes equal to codomain. So that means my function is onto. So it is going to be both 1 1 and onto. So that means my option number is correct. So that's all regarding your part 2 of relations and functions, in which we covered your exercise number 2. I hope whatever is taught is clear to you. Thank you so much.